All right, so the next question we have here, a pizza pan is removed at 10 p.m. from an oven whose temperature is fixed at 450 degrees Fahrenheit into a room that is a constant 71 degree Fahrenheit. After 5 minutes, the pizza pan is at 300 degrees Fahrenheit. So we have three questions to answer here. A, at what time is the temperature of the pan 135 degrees Fahrenheit? B, determine the time that needs to elapse before the pan is 160 degrees Fahrenheit. And then C, what do you what do you notice about the temperature as time passes? All right, so let's look at example A. At what time is the temperature of the pan 135 degrees Fahrenheit? Do not round until the final answer. And then we're going to round our answer to the nearest minute as needed. So as we work this question out, we're not going to round until the very end. So with this question, you need to know about Newton's law of cooling. And we have our formula here. U of t is equal to t plus, in parentheses, u sub 0 minus t times e to the k t, or e raised to the kt. So I have every part of the formula identified. U of t represents the temperature at time t. Our T, capital T, is the temperature of surrounding environment. The U sub 0 is the initial temperature of the object. And then K is the constant cooling rate of the object. And then our time, which we will represent in minutes, or is time is represented in minutes. So this is the formula that we're going to be using to answer each question, if possible. So the first question, it says, and I'm going to rewrite the formula again before we start here. We have U of t is equal to capital T plus U sub 0 minus capital T times e to the kt power. Oops, there we go. All right, so the question is asking us to, at what time is the temperature of the pan 135 degrees Fahrenheit? So our goal is we need to plug in the value so we can set up this formula to a smaller formula as we did in the previous examples where we talked about the growth and decay. Bring it down to something simple. So what's given? Let's go back to the story. We have, um, it says here that this pizza pan is removed at 10 p.m. from an oven whose temperature is fixed at 450 degrees. So that would be our U sub 0. Okay, that's our initial temperature. Into a room that is a constant 71 degrees Fahrenheit. So that's the temperature of our surrounding environment. So that would be our capital T. Okay, and I think that's all we need at this moment to set up the initial formula. So we have U of t is equal to 71 degrees plus 450 degrees minus 71 times e raised to the kt power. And let's subtract 450 and 71. So we have 71 plus 379 times e to the kt. All right, so let's It says here if we want to know, we want to find out at what time. So what is missing that we need to finish this formula is that we need to find K so that we can answer part A. Okay, so I'll say that this is the initial component that we have to find before we can actually solve question A. So let's find K so we can finish this formula. Okay. Now, if you look at the last sentence, it says after 5 minutes. Okay. Um, the pizza pan is 300 degrees Fahrenheit. So we're going to plug, substitute, excuse me, T in for, or 5 minutes in for T. And then we also have the temperature at that time in 5 minutes, which is 300. So that would be our U of T. Let's plug it in so we can find K. So we have 300 is equal to 71 plus 379 times e to the k times 5, which would be, we'll say 5k. Now we want to solve for k, so what we're going to do is subtract 71 to both sides. And we have 300 minus 71, which gives us 229 equals to 379 e to the 5k. We want our base e to be by itself, so we're going to divide 379 to both sides. And we have e to the 5k is equal to, now let's see what this looks like when we divide it out. 229 divided by 379. So let's go ahead and write this out. I would rather you write it out in decimal form than keeping this in fraction form and taking the natural log. So here we have, I'm going to write this out in pencil since it's kind of long. We have 0.06, excuse me, 0.6042216,359. Okay, so then we're going to take the natural log to both sides. So ln of 0.6042216,359 equals to ln of e to the 5k. We know ln of e to the 5k would give us 5k. Then we're going to divide 5 to both sides. And then what would k equal to? Okay, so let's go ahead and put that in. Now, if you wanted to, you could have said ln of 229 over 379, then divide that by 5 instead of having this in decimal form. But let's go ahead and I'm going to type ln of my previous answer and then divide that by 5. And you see what we have for k. K, we have negative 0.1007628,403. Now, this is just the initial setup so we can answer A. We haven't even answered A. We just setting up the formula so we can answer the question for part A. All right. So going back, we have our formula U of T is equal to 71 plus 379 times E raised to our negative 0.1007628,403 times T. All right. Okay, so let's go back to the question again. At what time is the temperature of the pan 135 degrees Fahrenheit? So we're going to substitute 135 degrees Fahrenheit in for U of T. So we have 135 equals to our right hand side. I'm not going to repeat that. Okay. Um, so solving, we want our base E to be by itself. So we're going to subtract 71. Then we're going to divide by 379 to both sides. So subtracting 71 to both sides, we have 64 equals to 379 E raised to the negative point 1. And we keep going. Then we're going to divide by 379. And I'm going to keep this 64 over 379 as a fraction, just so that you can see we're going to have a long decimal. Just keep it as a fraction for a second. So we have 64 over 379 is equal to E raised to the negative 0.1007628,403 T. So next we're going to take the natural log to both sides. And we have here ln of 64 over 379 is equal to negative 0.1007628,403 T. And then we're going to solve for T, we're going to divide this long decimal, which I'm not going to repeat again right now, to both sides. So we want to find T. So how to enter this into the calculator. So let's do this in parts. So we have here ln of, let's do 64 divided by 379, close it with the parenthesis, and then press enter. Then divide by negative 0.1007628,403 and press enter. Then we'll have our solution. So it says here, yeah, we are not to round our final answer, which we did not, as we're working out the question. But at the end, we want to round to the nearest minute as needed. So here we have 17.65. We want to round to the nearest minute, and the nearest minute will be 18 minutes. There we go. That is part A. Let's look at B. B says determine the time that needs to elapse before the pan is 160 degrees. Okay, so using our same formula that we have here at the top of our page, I'm going to rewrite it again. We have a new page here. So U of T equals to 71 plus, let me bring it down some, sorry about that, 379 e raised to the, our long decimal, okay, and it says 160 degrees. So we're going to let U of T equals to 160 degrees Fahrenheit. So let's plug those values, plug this value in for U of T. We have 160 equals to 71, our right hand side. Subtract 71 to both sides. Okay, divide by 379. Oops, sorry about that. 160, not going to, that's 89. I'm writing too fast here. So divide by 379. So we have 89 over 379 is equal to e to the negative zero point 0.1 and keep going. We're going to take the natural log to both sides. So our left hand side is ln of 89 over 379 equals to negative 0.1007628,403t, and take that long decimal and divide it on both sides. Divide it on both sides. And we have t is equal to. Now let's plug this information into the calculator. All right, ln of 89 divided by 379. Press enter. Then divide that by, I'm going to have to say it, we have negative 0.1007628,403. And then enter. And we have here 14.38, and we're going to round that to the nearest minute. Okay, and that will be 14 minutes is our solution. Now to answer part C, what do you notice about um, what do you notice about the temperature as time passes? This is part C. So for part C, the temperature of the pan is approaching 71 degrees Fahrenheit. And there we go.